So we spend a lot of time with quadratics with that idea of no solution. And when you took your quiz on Friday, there were certainly problems in which you had no solution. So what we're going to do is begin to look at a way to address negatives under a radical in a different way. I like to think of it as someone came along and said, you know what? I know that everyone's saying, write this down, that if x squared equals -1, that can't happen. Someone came along and was bothered by that fact and decided this is going to be a problem because we need to address this issue that x squared can't equal -1. Normally you would say, no solution, or a lot of us would say this. Okay, fine, I know I'm supposed to take the square root, so now I have x equals plus or minus the square root of -1. Well, who cares? Our original premise has been, you know what? We can't take the square root of a negative number, so we state no solution could exist. Now, to be clear, why have we said x squared cannot equal -1? Why have we said that, Aaron? Excellent. I cannot take two numbers, multiply them together as the same number, and get a negative. Because I'm either multiplying a positive times a positive, which is positive, or a negative times a negative, which is either way, I can't have a square equaling a negative. Until someone said this. Let's take and create a new unit. And let's say that the square root of -1, which is my most basic issue here, let's call this I. Let's call this place where we have an issue, let's call it, hey, I don't have an answer for it. Seems like it doesn't exist. Let's call it an imaginary number. Now, this is the most important basic understanding of an imaginary number. But it has properties. So we're going to start to delve into how does this I work. So here's an example. Let's say I have this basic definition of I equaling the square root of -1. Okay, well, what happens if I square I? Now, Aaron just said that if I square any number times itself, it's going to be positive, but what happens if I square, write this, the square root of -1 times the square root of -1? Well, in order to talk about multiplying two square roots together, I have to, for a minute, just remind ourselves, well, what does it mean, let's say, to take the square root of 9 times the square root of 9? What is the square root of 9 times the square root of 9? 9. Why? Because essentially the square roots cancel out. If I take the square root of 9, I get what? Times 3 is 9. That's one way to think of it. Here's the other way to think of it. I don't know if you heard what David said. He's like, it's basically like the square roots cancel out. If I take the square root of some number, that means what number times itself gives me the answer. Well, if that square root times that square root is multiplied together, I get the answer. If you're with me, raise your hand. Okay, so what if I gave you this? Square root of 13 times the square root of 13. Do I need to know what the square root of 13 is? No, what is that? 13. So following the exact same pattern, if I take the square root of -1 times the square root of -1, what do I get? -1. And now for the first time ever, I can do a square root and a square root and get a negative. If you're generally with me, you might find it weird, but if you're generally with me, raise your hand. Okay, so what happens if we cube I? Well, what does cubing I come from? Say it. This is my hand. Say it, Claire. I thought you were saying it. I times I times I. Okay, so this is I times I times I. But what did we just say I squared is? Negative 1. This is just negative 1 times I. So what is I cubed? Negative I. So I is just itself, or square root of negative 1. I squared is negative 1. Now we've said I cubed is negative I. You with me so far? Okay. Now, I don't want you don't have to write anything down. I just want you to talk about how would you discover I to the 4th. So there are 5 to 6 of you in a group. You can either talk through it together or pair up really quickly. But I should hear at least 3 conversations going, maybe 5 or 6. Go. Yeah, that's good. That's good. Okay, I hear some ideas out there. I'm going to have Ella repeat it just because I happen to hear it. What did you say, Ella?
I times I times I times I.
Isn't that what this means? 1, 2, 3, 4. But if I think of this, what is I times I? Negative 1. What is this then, I times I? Also negative 1. What's negative 1 times negative 1? 1. Okay, now, using a similar process, I want you to find I to the 5th, I to the 6th, I to the 7th, and I to the 8th in your groups. Go.
So it's negative 1 times the square root. So then I get, and then the square root of negative 1 is I. So when I get the I. Then you just get like 1. So it's like this. So you get negative 1 times 1. But then I is the square root of negative 4. So then you get I.
That'd be 1 times I.
Yeah.
I to the 4th.
It's just 1 times I.
Negative I times negative.
I actually don't know what.
Wouldn't that be negative I? Because it's
I know it's negative 1 times negative I.
I to the 4th is 1.
What'd you say?
I to the 4th, so the I to the 4th.
Oh, wait.
So if you like it,
I to the 7.
Well, I just feel like I just
I
I to the 6th.
negative I.
Right?
I don't know. Well, it's did you get I?
So I is equal to
I
square root of
square
negative
root
1.
of negative 1.
Yeah. So you just call it
Okay, so I will tell you, I just heard some really
negative 1.
good conversations. So I want to make sure we're on the right track, even though I especially appreciate the conversation going over here. Okay, what did you decide on I to the 5th?
Negative
I.
It's I. Okay, if you got I, will you raise your hand? Okay, Ethan, how'd you get I?
So, I to the 4th is 1. So
Yep.
I just did 1 times I, which is I.
Perfect. You see what he did? Okay, what is I to the 6th? How about a volunteer? Negative 1. Okay, now You should already start to see a pattern. I've lined these up on purpose like this. Okay, how'd you get I to the 6? Can I take a volunteer there? Go, Carter. Yes. Okay, so he's saying I squared times I squared times I squared, but that's just -1 times -1 times -1. Love it. That's good. Okay? Without doing any work, can you take a guess at what I to the 7th is? Negative I. Sarah, what are you noticing? Why would I not need any work?
Because it's the same as like what's next to it.
Yeah, it just matches over here. It's not a coincidence. This is a pattern of 4. What is this next one going to be? 1. If I literally went through these every single time, I would keep coming up with that same type of pattern, and in every single type of pattern, I would end up with this I, -1, I, 1. I, -1, I, 1. So, for the record, pretend I didn't have 5, 6, 7, or 8 right here. I could go I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. Where would I find I to the 5th? Back up to the top. I to the 5th, 6th, 7th, 8th. Using that method, will you please find I to the 23rd in your groups and raise your hand when you give an answer?
This one we took on by 4 is so we tried it, you would nothing. So then 20 would be the 4th one. 21, 22, 23.
Yeah, Carly, say that a little louder for everyone here.
Okay, well I did 20.
What did you get, first of all?
I got -I.
Totally agree. Okay. What'd you do?
I found the first like thing that could be divided by 4. So I did 20 divided by 4 is 5. And then I was like, just so that would be on the bottom one, so that would be 21 would be the first one on the top.
Do you hear what she's saying? Okay, she's saying, look, this is a pattern of 4. So if I figure out how many times I go through the pattern of 4, I will have gone 5 times. And on the, I heard Carly say, on the 20th one, where am I?
You're on the bottom one.
Yeah, so then how many more do I have left?
3.
21, 22, 23. Now, who just flat out counted? That's fine too. Yeah, because you got the same answer, right? Okay. The only thing I'm going to tell you is, I'm going to set you loose here in a minute. The higher the number, the more annoying it is to go 1, 2, 3, 4, 5, 6, 7, 8, top, 9, 10. You with me? Nod something. Okay. So this division idea is very helpful. Okay? So I want to talk through this really quickly one more time. Why is she dividing by 4? Why is she dividing by 4? Because it's a pattern of 4. So do I totally care how many times I've gone through it? No. That tells me I go through the pattern 5 times, that's fine, but when I this is really 23 divided by 20. She just picked 20 because she can see it, but if I give you a really big number, it's going to be annoying. So think of this as 23, let me change. 23 divided by 20. This goes in 5 times. I'm left with 3 as a remainder. Guess what that's telling me? The third one down. I go through it 5 times. 1, 2, 3, 4, 5. I land here. I have a remainder of 3. Go 1, 2, 3. If you're with me on the division, raise your hand. Okay, you're going to need that because eventually I'm going to give you I to the 1,322nd, right? You can't count that many. I mean, you could, but you cannot. You don't have time. Okay, using the division, will you find 36, 85, and 42? Go. Are you able to win? That's dangerous. Yeah. Santi. That will work certain times, but not all the time. It'll work when it's a number that's 6 and 4 going 2 together. quiz score. This is one of the ones that was cut in half. So it went in as a score out of 35 instead of a score out of 70. Okay. Answer to I to the 36. Raise your hand if you're good. If you're good. Okay, Jackson, what'd you get?
I got just one.
Yeah, why? When I divide, what is my remainder?
0.
Yes, perfect. I to the 85th. How about that one? I to the 85th, Jonah. Totally. If you are in agreement, will you raise your hands? Anyone need me to talk through these a little differently? Okay. Yep. You divide 36 by 4. This goes in 9 times. This is left with 36. There's a remainder of 0, right? When I have that remainder, that's telling me I end at a factor of 4. So I go 1, 2, 3, 4, 5, 6, 7, 8. You hear how multiples. You hear the multiples land on that one? 12, 13, 14, 15, 16, 20, 24, 28, 32, 36. Okay? Okay. I to the 42nd. Oh, yeah, Abby.
Wait, will you go over the 85?
Yeah, who gave me the 85 answer? It was somebody. Jonah, tell me how you did it.
I took 84 divided that by 4, and because the 1 was a remainder from that.
I would have done it this way. Yeah, I don't disagree. The only thing is, if you don't see 84, you're kind of in trouble. So just take it, the number, the power, divide by 4. It goes in, like, he went ahead and found out. He knew that was a multiple, so he just didn't worry about it. I would say this goes in, and you can use your calculator if you want to check. This goes in twice, sorry. This is minus 8. That's bring down to 5. That goes in once. Minus 4. What am I left with? A remainder of 1. So this means I went through the pattern 21 times, and at the end of the 21st, I landed here. I had 1 left over.
Okay.
Is that better?
Yeah.
42. Who's got an answer? Go, Carly.
-1.
How did you get it?
I just did the long division thing. So then you do 4 goes into 42. The 4 goes like 1.
Yeah.
And then you bring it down to 0, then 0.
Yeah.
2 remainders.
Here's 2 remainder. Yep, that's right. Okay. How's that seem? Decent? On the next slide, we start to look at where we're headed tomorrow. With this idea being that we need these imaginary units so that I can solve a quadratic equation in particular, and in a couple weeks, a cubic or a quartic or all sorts of different polynomials. We can find the zeros, the roots, the answers. Now, especially if it allows me to do things such as taking the square root of a negative number. So if I had an answer, let's say on your quiz from Friday, that was plus or minus square root of negative 18, you would have said no solution. Now, we're going to break this up. We're going to break it up. Box in that first step, please. Box in that first step. We're going to break it up into what I would consider what's going to be the imaginary part and the real part. So I take the -1 off. I get -1 times 18. I know from my rules of square roots that I can split those up. If you're with me so far, raise your hand so I know you keep going. But the square root of -1, what do we now define that as? I. Good. I'm left with the square root of 18. Well, I haven't stressed reducing radicals. That's about to change. We're going to now reduce our radical to 3 root 2. This answer is considered 3i root 2. So with your groups, will you now evaluate, or rather simplify, A, B, and C? Go. It's like a faulty claim. This is not purpose-building. Okay, you ready? Tell me how to write out 1A. Tell me how to write out 1A. Go, Morgan. Yep, negative 1 times 12. Then I take the square root of negative 1, square root of 12. Square root of negative 1 is I. What is 12? Square root of 12 reduced to? 2 square root of 3. Now, I got some chat over there. Listen right here. Check your letter A. It should read 2I root 3. 2I root 3. Now, letter B is nice and quick. Negative 1 times 25. That's just simply I times I, which we write as 5I. Are you okay with that?
Yes.
Okay. And then the last one, I write the way Morgan said, but that does not reduce. So we leave it like that. Okay? Any questions on the problems there in number 1? Okay, so now we're going to put two things together. We're going to put a real number and an imaginary number together at the same time. And when we do, we refer to it as a complex number. We're going to almost always be required to write complex numbers in standard form. We call that standard form A plus BI. A is the number we've been dealing with your whole educational career. This is the real part. It's the part you know. But now we can add on an imaginary part. Now we can add on an imaginary part. And when we combine them, we are in what we call the complex number system. Now the truth is, just to put a little context on it, you've been told this for a while. You may remember a picture like this. Our most basic number system is our natural number system, followed by, which is all of our counting numbers, followed by whole numbers, which are counting numbers in there, and 0. If you kind of remember this, raise your hand. Okay. Followed by integers, which is counting numbers 0 and their opposites. Followed by rational, which is anything that can be written as a fraction or a decimal. And then you were told there was this other category called irrational. Anyone remember that? And you were often told this is called your real number system. Real, as in not including all of our imaginary. So when we tack on our imaginary, what we then have in combination is in reality what is happening in the real world, which is numbers in the complex number system. The number 7, it's a complex number. It's just you have 7 plus 0i. What is the imaginary part? 0. You've been dealing with these, you just didn't know it. Well, now we're going to look at numbers that are complex. We're going to simplify them. We're going to add, subtract, multiply, and divide them. Some of this will go pretty quick. So, for example, I can take 3 plus 4i plus 2 plus 5i, and I can put the combination into standard form. I's work like variables, with a few exceptions. But for example, if I have 4i and 5i, how many i's do I have? 9. So I'm going to put the imaginary part last. I'm going to put the real part first. I I've got 5 plus 9i. If you're feeling like that's easy, raise your hands. Okay, in your groups, crank out 2 through 4. Go. Hey, I'm going to take your extra credit just so you know when I'm going to pitch it, unless someone's desperate to have it. You would have seen it go in. And I also have your extension assignment, which people did overall really well on. Here you go. Abby. Jonah, are you done? We put the score on the front. And Ian, I think Ian's too, right?
Is Ian not here?
No. Sorry. Thank you. Okay, if you're done, raise your hands. Just so I know I can go. Okay, here we go. What is my answer to number 2? Can I take a volunteer? Go, Claire. Okay, just give me a really quick, like check-in. If you're fine, give me a thumbs up. Not sure, down. Okay, good. Number 3, Aaron. 7 minus 7i. Where are you? Okay, last one. Ella.
-2.
Plus, be careful there.
7i.
Yeah, very good. Good adjustment. Where are we? Good. Okay, so this is referred to as several things. First of all, it's referred to the idea of putting your complex number in standard form. Okay? It's the idea of putting your number in standard form, a plus bi. It also is actually the beginning of addition and subtraction. So notice, even though we didn't say, hey, this is specifically, let's add and subtract these in the directions. That's really all you're doing. Okay, so we're going to add or subtract. We're not going to kill this topic. I just want you to do number 10, please. In your groups, do number 10. Go. This time while you work, I'm going to write out steps up here. And you can check when you're ready. Okay. If I had to label the real part, Jonah, thank you. If I had to label the real part, what would I call it? What's the answer? The real part is 0, and the imaginary is, we're actually going to call it just -5. So it has to do with the coefficients themselves, the numbers themselves. So the real is the 0, and the imaginary is -5 only. Got it? Okay, we can add and subtract. We also can multiply. Now, the steps remain the same. So if I take 3i, what do you think I'm going to do with it here? I'm going to distribute, right? That's fine. This is one of the few times we're going to write out the steps. So write this out. 3i times 1 minus 3i times 4i. Okay, now, are you going to have to write that out every time? Absolutely not. But we got to double check here that we don't forget something. Got an idea?
I know, I just have a question about the last one. Do we
Oh.
need to write the 0 minus? Or can we just write
Generally you can
-5?
just write -5i. That's fine. Okay, Part of this is easy because 3i times 1 is 3i. Now, watch closely. This is minus what number? 12. But then you have I what? Okay, flip back. What is I squared? Louder. -1. So really, this is 3i minus 12 times -1. Well, again, you won't always have to show all these steps, but this is 3i minus what kind of 12? Yeah, -12, but that's really 3i plus 12. And I'm going to always get in the habit of writing my answer in standard form. So can I leave it like that? No, I need to flip it. 12 plus 3i. Now, the rules and properties of equations and, a better word there would be expressions. The rules and properties of any type of expression in terms of order of operations still applies. We're still going to PEMDAS it. But the exception is when I have an I times an I and I get I squared, I have to change it. When I get an I cubed, I have to change it. When I get I to the fourth, I have to change it. In your groups, please, will you do 12, 13, and 14? Okay, so I want you talking through these steps, please, if you would. Yes, good. See that group talking over there? There we go. Okay, so compare your answers. Did you get an answer for 12? Did you get an answer for 13? Can you distribute the square in number 13? That's a trick question. Can you distribute the square in the 13? No! That hurts my heart. What does 4 plus 3i mean? You like FOIL it. Also known as you just straight up FOIL it. You like FOIL it, you like foiling, so you FOIL it. I don't think anyone's really appreciating my sense of humor right there, but it's okay. Hey, are you quiet because you're done? Have you compared in your group?
We're waiting for better.
Okay, how about now if you're done? Raise your hands. Anyone need more time? I'm going. I got 7 minutes. And I might actually be able to get done. Okay, if you need more time, this is your last call to raise your hands, otherwise I'm gonna randomly call on people. Okay, go, hurry. Ready? Here we go. Starting with Aaron, number 12. Yep.
I did 5 plus 2i plus 15i plus 6i.
Oh, 5 plus, I see, 5 plus 2i plus 15i plus 6i squared. Good. That's pretty close to what most people should have. What can I put together, Jackson?
The 2i and 15i.
Yeah, and I get 17i. That's going to be my imaginary part. Santi, what do I have to do with that 6i squared?
You,
I don't know what that was. Keep going.
you foiled that? Or no, you.
What is I squared equivalent to?
Oh, -1.
Negative 1. Good. So this is 6 times negative 1, so that whole thing is negative 6. What is 5 plus negative 6? It is negative 1. If you're okay with that, raise your hand. Jonah. Good idea. Okay, Sarah, start the other one.
So I foiled it into the 4 times and
Yep.
then I got 16 plus 12i plus 12i plus 9 times I squared.
Okay, so these two are,
24i.
yep,
And then change the 9i squared to 9 times negative 1.
which is negative 9 for a total of,
For 7 plus 24i.
bingo. How we doing there? We okay? Last one, I'm going to go pretty quick. You ready? I'm going to foil this out or distribute this out. This is 64. This is plus 24i minus 24i. What happens to those? Cancel. This is minus 9i squared. But we know this is 64 minus, what is this really? Negative 9 for a total of 73. You should find something interesting about that problem. What is it? I just eliminated the i's. Did you hear what David said? Everyone agree I just eliminated the i's? What caused the i's to go away? The outside inside cancels. We're going to use that for our final steps today. When we divide a set of imaginary numbers, it looks just like a funky fraction. And the rule is you cannot divide and leave it. You have to adjust it. So what we do is, and I'm going to start right here to begin, we got to multiply by something that gets rid of the I. So this is the last one we'll do today, and then we'll pick up where we left off tomorrow. What do I need here in the denominator to get rid of that 4i? What causes the i's to go away? If I had an I right there, and an I on top, because I have to multiply by, this has to be equivalent to 1. If you're with me on that, raise your hand. Okay. Well, what is on the bottom now? 4i squared. But what is that? Negative 4. So watch this now. On top, I still have to distribute. I still have negative 5i plus 3i squared. If you're with me on that, raise your hand. Right? This still has to go to that. But if my end goal is to always write my answer in standard form, and now all of a sudden I have, this is going to be negative 3 plus negative 5i. If you're with me on that step, raise your hand. Okay, let me say it again. This is distributed, right? Negative 5i plus 3i squared. You okay with that? But I squared is negative 1. Agreed? So this is just negative 3, so I can rewrite negative 3 plus negative 5i. Okay, watch this last step. I've referred to it often this year as the butterfly effect. If I divide those, I then have to also divide that. But now I am in standard form. Make sense? Yep. Nope. Why?
It starts off as negative 3, but then I squared is
Ooh, yeah. Sorry. Yeah, you're right. Yeah, so this would have been minus 3i. Yeah, thank you. And then, did you hear what she's saying? Will you fix that real quick? Sorry about that. So this would have been a negative 3i squared, but that'll become positive 3, but that'll make that negative. Did you see what I did there? Yeah. Okay. All right, so your homework is going to be a combination. You picked up 2 worksheets, but you do not have to do all of it. I'm going to start with the worksheet called Simplifying Radicals. Do you see that one? Answer keys are on the back. You are going to do numbers 5 through 20 all. Notice that's going to go pretty quick because it's just adding and subtracting at the bottom. And then on the complex numbers worksheet, you're going to do just numbers 7 through 12 all. Okay? Answers are on the back. Everyone clear what you're doing? All right, good work today. Thank you.